Hello, in this video I'm going to show you how to create an additive harmonic synthesis patch by using the MC objects. This is going to be our introduction or entrance into the world of MC, multi-channel objects in Max MSP. We're going to look at how to create a basic multi-channel oscillator, how to control it by increment, deviate, and harmonic messages, and how to automate the individual amplitudes of each sinusoidal component by using yet another multi-channel LFO. This is going to be the beginning of a lot of cool patches that explore the MC world of objects, which make a lot of things not only easier but just plain possible. So let's begin. Alright, let's imagine I want to create a sine wave oscillator, I want to control its volume, and then I want to play it out from my speakers. Then I would create cycle tilde, the quintessential sine wave oscillator in MSP. I would give as an argument 220, that's a nice frequency, and then I would create live.gain to use it as a volume slider. I would connect these guys like this, and then I would create EZDAC tilde for my audio outputs. Very simple stuff, the basics of working with MSP. But now here's the question. What if I wanted to do additive synthesis? What if I wanted to have multiple instances of the sine wave oscillator? Right, let's say we got 5 here. I'm going to create another 5. And I have these 10 instances, these 10 copies of a sine wave oscillator. And I want to be able to change the frequencies and amplitudes separately. I want to put them together. I want to work with them to create cool new timbres and sounds. Now, this is a lot of work to connect and coordinate all of these objects, right? And this is how it has been done in Max MSP for a very long time. There are dozens, maybe hundreds of patches that deal with additive synthesis like this. But in a recent update, Max MSP now has multi-channel objects, MC objects. So instead of creating cycle tilde, I can just type in mc.cycle tilde. And you can do this for almost any MSP object. Almost all MSP objects have a multi-channel version that starts with mc.cycle, mc.snapshot, mc.sig, and so on and so on. And what these MC objects do is, well, first of all, they send out a different kind of patch cord. These are not the regular audio signal, but multi-channel signal. They behave a bit differently, as we are going to see. And second of all, we can in fact specify how many instances of the original MSP object this multi-channel container is going to, well, contain. I just have to use the attribute chance, so I can specify the number of channels and instances in the MC wrapper object. So if I type chance 10, I'm going to have 10 instances of my cycle of my sine wave oscillator. So this and all of these are the exact same thing. This is just a much more streamlined, maybe a bit more intuitive and easier way of dealing with multiple instances, multiple oscillators, MSP objects, audio techniques, and algorithms at once. So I'm going to delete all of these copies of cycle because we are going to be using mc.cycle. Now, to play back multi-channel objects, you need to use a few more objects. Well, the most essential one is, of course, mc.mixdown. This is going to mix, literally mix down. It's going to mix a multi-channel signal into a stereo or mono signal, right? And as an argument, I need to give how many channels there are going to be in the output, and let's make it stereo. I can also do a nice thing and add the auto gain, turn on the auto gain attribute, which is going to scale the overall gain by the number of output channels divided by the number of input channels, and so it's going to make sure the balance of the amplitude is just right. And after I connect this to the outlet, to the output of my MC cycle, I can go ahead and create mc.unpack, unpack tilde. Again, I need to give it an argument of the size of the incoming multi-channel signal, and in this case it's going to be 2. We're going to receive a 2-channel MC signal from mc.mixdown. So if I type mc.unpack2, I connect this cable here. Notice how this patch cord is containing 2 channels, right? It's going to send the stereo channel like this, and the unpack object is going to literally unpack these into good old regular mono audio signals. after which I can connect it back to my live gain and I can just play it in any way I want. Now, there is no sound because MC cycle has no attributes nor any kind of messages, so I can just send it, let's say, 220 yet again, and we are going to hear the exact same sound because all instances of MC cycle are playing the same frequency. So let's talk about how we can get multiple frequencies in there, how we can get MC cycle to play a lot of different frequencies at the same time. So to do this, I'm going to feed the frequency information by using mc.sig. I'm going to literally send the frequency information as an audio signal. I always prefer doing it this way, and especially in the case of using MC objects, this is much more useful. I again have to specify the amount of channels, and since I'm going to connect this here, I in fact do not need the chance attribute on my MC cycle. Now this is because the MC sig, the first object from which the MC signal originates from, is already sending out 10 channels. Now when this arrives to MC cycle, even though I have not specified how many instances of cycle is going to be contained here, it will know that it will need 10 cycle objects because it is receiving a multi-channel signal of 10 channels. So the chance attribute is only necessary for the very first object in your pipeline, the very first object that sends a multi-channel signal. After that, you can just connect your MC cycles, MC mixdowns, MC unpacks, and they are going to know exactly what to do when they are receiving, let's see, there we go. They're going to know what to do, how many channels to send out. Now let's see what we can do with this mc.sig. Now there are 3 messages that I'm interested in: deviate, harmonic, and increment. And well, let's look at increment and harmonic. We can get to deviate maybe in another video. Now all these 3 messages in fact work in a very similar way. So you have to, for instance, create a message that says increment, and then you have to add 2 floating point numbers, right? So this is the structure of the increment message, also the structure of the harmonic or the deviate messages. I can then connect this floating point number box here, and now let's see what increment precisely does. So the increment message generates an increasing value for each channel starting at a specified value. If no message name is provided, then a float message is used by default. Okay, kind of get it. It is still a bit esoteric, but let's see how we can use it. So as I've said, increment needs 2 inputs, like we have increment and then 2 floating point numbers. Now the first number, the first value, is the amount of the increment. And the second number is the frequency or the number, the value from which we begin. For instance, if I type in 100 as my second value and I type in 10 as my first value, I'm just going to turn off live gain. Let's just look at these individual signals themselves. Now look at what mc.sig is sending. 10 channels, and each of them have a different value: 100, 110, 120, 130, 140, 50, 60, 70, 80, 90, and so on. It is starting with 100, and on each instance, on each audio channel, it is incrementing this by 10. Let's see how this sounds. Okay, kind of a drone-like sound. Maybe we can put it a bit higher. You can really play with this. This might create a lot of cool drone-like buzzing sounds. Maybe you can automate this increment value in order to simulate the movement of a motor and so on. It's super useful, it's super cool. But let's also look at the harmonic message. I'm more interested in that for the purposes of this video. So I'm going to create another pack object, pack harmonic 0, 0. Now let's see what the reference has to say about the harmonic message. The harmonic message generates a harmonic series using the second argument as a fundamental frequency and the first argument as a multiplier. So again, it's the same logic, right? We use the second value, the second number, as our starting point. So let's say we start with 220. And now if I type in 1 here, this is going to generate the harmonic series taking 220 as the base frequency. So the sound is off. Let's look at the values: 220, 440, 660, 880, 100 and 1100, 1320, and so on and so on. Changing this first value will change the multiplication of the harmonic, right? So if I make this 2, then it is going to kind of skip over each harmonic. It's going to double the amount added to each harmonic. Maybe it's easier to understand if we just listen to it. There we go. So now I'm going to turn off all the harmonics. All harmonics are multiplied by 0, which means we're just receiving a bunch of 220s. And now all the harmonics are present. This is much fatter sound, right? And we can again mess with this value. Bit of a 50s, 60s robotic early musical experiment sounds in there. Okay, so what we have just done, in fact, is additive synthesis. It's not very intricate additive synthesis. I would say it's not even very good additive synthesis, but it is additive synthesis nonetheless. We are taking different sine waves, we are assigning them different harmonic values, different frequency values, and then we are putting them together to get different kind of timbres that are based on a singular frequency. Now let's do something else. Let's try to see if we can change the amplitude of each harmonic in our 10-channel additive synthesis generator patch thing. All right, so I'm going to keep it like this: harmonic 1 to 20. So we have a harmonic series that are 10 steps long, that are 10 instances long, and the multiplication value for the harmonics are 1. So we are just receiving the pure harmonic values. Fantastic sound, just like that. Now, how do I want to change these harmonics? Well, first of all, I want to create a multi-slider. I'm going to control the amplitudes by the means of multi-slider. I'm going to give it a few attributes, such as size. I want it to be 10 sliders long. I also want it to have a range of 0 to 1. So I'm going to type in set min max 0, 1. Set style should also be 1, so it looks a bit nice. And I also want to give it the attribute of, let's see, cont data, continuous data, 1, so that while I'm changing the slider, it is still outputting the values. It doesn't wait for me to release the mouse. Okay, let's make this guy a bit bigger and we can kind of see the UI with which we are going to work. Fantastic. And if we look at the output of multi-slider, we can see that it is sending out a list containing all of the values of all of the sliders. So we can use this, right? If I want to change the individual amplitudes of each sinusoidal component of my additive synth, I can take these numbers, these 10 numbers, and I can multiply each instance of my MC cycle with these numbers, which is going to give me very fine control over the amplitude. Now, how to do this? Well, it is in fact really simple. As you might have imagined, we are going to use the MC dot multiplication operator, MC dot asterisk tilde, which is going to multiply two multi-channel signals. But of course, just like how it is, let's also give it the initial multiplier of 1. So if I haven't done anything, it just passes through. What was I saying? Okay, so just like how it is with MSP, instead of sending a signal here, and at the end we are going to send a signal here, but for now, we can just connect a floating point number. Regular, we can send it a floating point number, right? And just like before, this is going to apply to all 10 channels. It's going to multiply, let's say, all 10 incoming channels by 0.1, so it's going to make it much, much, much softer. But what if I want to take this list of 10 values and I want to tell MC.asterisk, MC.multiplication, hey, take this list of 10 values and take the first one, multiply the first channel with this, the second channel with this, the third channel with this, and so on. Well, there is a message that deals exactly with this, and that is apply values. This is a very useful message, a very useful syntax, let's say, when working with the MC family of MSP objects. And let's see what it says about it. the word apply values followed by an optional message name and one or more message arguments sends individual values in the arguments successively to instances in the MC wrapper, starting with the first instance. For example, the message apply values 4, 5, 6 will send 4 to the first instance, 5 to the second instance, and 6 to the third instance. Okay, that's exactly what we need, which means we need to prepend this list with the message apply values. There we go. If I just plug this here, now when I'm changing this multi-slider, I'm going to get a message that begins with apply values and then these 10 numbers, 10 floating point numbers. So let's connect it back to our MC. I'm just going to put it in the first inlet. It doesn't matter when we are sending it with apply values. And now if all of these are off, I'm not going to hear anything. And now look what happens. I don't know about you, but I can personally play with this all day. It's really fun and again gives us more fine control of the individual components of our little additive droney synth. Now, one more thing I want to do is to automate this. Why, since we have come this far, why don't we also add an LFO in order to control the values of these guys, more specifically? And since we are using a lot of MC objects, I want to use another MC.cycle, and I also want to give this 10 channels. But instead of making sound, these are going to control my multi-slider. These instances of cycle are going to control my multi-slider. So just like before, I'm going to create an MC.sig. Well, I'm going to give this my channels. MC cycle doesn't require the channels attributes, and this time I'm going to use the increments, right? Let's say I want to start with 0.1, so like very, very, very slow, absolutely inaudible oscillation. And each time I want to add, let's turn this off and turn this on, and each time I want to add another 0.1. Right, so now my MC.sig is sending 0.1, 0.2, 0.3, 0.4. All oscillators are oscillating at different rates yet again. Okay, so now we just have to extract this information, and we can do this by using the MC variant of snapshot, which is going to convert signal values to numbers. And again, I don't need to specify the amount of channels because it's going to know what to do when it receives the multi-channel. In fact, what it is specifically going to do is to send out the signal value from its first outlet and the voice number from its second outlet. So it's not going to send all the values as a list, but it's going to send out, okay, number 1, this value, number 2, this value, number 3, this value, and so on. So I want to regulate this a bit better by using mc.route, which is going to direct the output of messages based on an index received. And we have our index right here in the second outlet of MC snapshot. Right? As an argument to MC route, I'm going to tell it how many outlets to create, how many individual messages it's going to get, how many different channels there are going to be. And then if I connect this here, I can simply pack all the values I'm receiving. Right? I'm going to use pack and then 0, 0, 0, 0, 0, 0, 0, 0, 0, and guess what? 0. That's 10 zeros, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. And as soon as I connect all of these guys together, I should indeed receive a list that contains the amplitude of my 10 channel sine wave oscillator that I'm going to use as an LFO. Let's see. So if I 0.1, 0.1, and why isn't it working? Because MC.snapshot requires an argument for the reporting interval. So let's say I wanted to tell me the the value converted to a number every 33 milliseconds. There we go, it's working. So now we're getting this list of values. Notice that since this is a sine wave, it goes from -1 to 1 instead of 0 to 1 like I wanted. So I can use the MC variant of scale tilde MC.scale tilde, and then I can say I'm going to receive a signal that goes from -1 to 1, and I want to scale it to 0 to 1. I can put it right below MC.cycle, put it in here like this, and now I should be receiving this list of 10 numbers all going from 0 to 1 and back to 0 in a sine wave oscillating fashion. And I just have to plug this here. There we go, automated movement. We can even see how that sounds. I can again play with the increment values. And while it looks cool, you probably have noticed the clicks, right? Since these values are being sent very rapidly and they do not always match up with the signal rate, there are a few clicks there as the the audio values or the signal values are jumping. They're not very smooth. To fix this, instead of sending all of this information via apply values, I can take the output of mc.scale. Right, which is an audio signal containing the values I want to multiply my my audio MC cycle with. So doing this will ensure what is happening. All this multiplication is happening at signal rate, which means almost no clicks. Actually, no clicks at all. And we can still keep our multi-slider for visualization purposes. It's really cool. You can even see the shape of the sine wave in the shape of the multi-slider. And if I really slow this down, I'm going to get this soundscapey, evolving sound. It's really cool. So there you have it. This is maybe the base of a lot of future projects, future patches, the beginning of a additive harmonic synth patch. Right, we can connect this to a keyboard, we can make it trigger samples, we can create an even more of a shimmering effect by exploring beats, and we are probably going to be doing some of these things in the future videos. But until then, I hope this has been useful to you, and thank you for watching.